I should start by introducing myself. My name is Mark Gray. I'm the head of scientific platforms at Pawsey Supercomputing Research Centre. I'm in charge of everything at the centre with a blinky light, and my team work to keep all those systems going. And those systems are the supercompute systems, the storage systems, which is what we're here to talk about today, our on-premises cloud systems, and the networking systems that keep all those things working together. Supercomputing is the primary purpose of the Pawsey Supercomputing Research Centre, but supercomputers don't work without big storage systems to hold the data that researchers are using and creating as part of their work. So at Pawsey, we also run big storage systems to complement our big supercomputing systems. At the moment, across all of our infrastructure, we're running about 300 petabytes of storage, which is a lot. So a typical laptop hard drive of the sort most people are familiar with is a few terabytes of storage, and a petabyte is 1,000 of those all together, and we have about 300 petabytes. So it's kind of like 300,000 laptop hard drives all running together across this big system. Yeah. The storage systems themselves, though, are not hard drives. Most of our storage is held on tape. Some people are surprised by that. They're wondering why we use such an old technology to operate storage, but it's still one of the most cost-effective and cheapest to operate storage systems you can get, and that's why we run a lot of it. Right now, we're running about 140 petabytes of tape storage. That's our main system, and that's not usable storage. Usable storage is about half that because we run those tape systems mirrored from one system to the other, and that keeps our researchers' data safe. We also run a large disk-based object storage system. That's a raw storage, about 90 petabytes, but about usable storage, about 60 petabytes. And then we also run a bunch of other large, very fast storage systems for researchers that are directly attached to our compute infrastructure. And there's probably about 20 petabytes of these very fast file systems. And those aren't really used to store data. Like, people don't leave data there for a long time. They're used to actually just provide processing storage for researchers that are running jobs. And when those jobs are complete, those data need to get moved to some of our either object storage or our tape storage systems.
So can you tell us a little bit more about these new systems that we've just deployed, Acacia and Banksia?
So as part of the Capital Refresh, we've deployed two big new storage systems: Acacia, which is a big object system, and that's based on hard drives, there's a lot of them, and then Banksia, which is our big tape system. In our Capital Refresh, we knew we needed to make some changes architecturally to the way our storage worked. And so Acacia is a big object storage system. And what that means is that when researchers are using data on that system, essentially they use it as a place where they can put data and also extract data, but it's not something that is directly attached to our compute facilities. So if you want to do work with that data, you normally need to move it to a compute system, do your work, run your work, and then put that data back on the object system. And that's all disk space. It's very fast and very available for researchers. And it's particularly well suited to researchers that have kind of workflows that require them to share data with other researchers external to Pawsey or even within Pawsey itself. And then we have Banksia, our big tape system. And that's really intended for large, high volume data sets that don't need to be accessed every minute. Tape itself is intrinsically slow compared to disk, but it's a lot cheaper to operate. And so we run a lot of it. And so collectively, these systems allow us to both store large, relatively quiet data sets, as well as fairly large, busy data sets that need a lot of fast access.
Nice, thank you. So we've recently procured and deployed this architecture. How did we determine that this was the best solution for Pawsey researchers?
So at Pawsey, we've gone through a long process of working out exactly how we wanted to architect this collection of storage systems to provide a good research storage system for Australian researchers. The very first part of that was probably started about 3 years ago. We went through what's called a procurement process called a request for information, an RFI. We went out to the storage vendors of the world, and we didn't ask them for bids on buying something. We kind of went to them and said, here's what high level we're trying to do. We're trying to build this ballpark about 300 petabyte storage system that needs to do lots of different things, be useful for lots of different kind of research workflows. And we asked them for their view on how they would do that. We've got like a lot of responses. I think we got about 13 different responses from the storage vendors of the world on how they thought we should do that. So that was like our first data collection on, what kind of storage system should we build? Because our first question is, what can we build? The other question is an equally important one, was what do our researchers actually want to do with this storage? So we went through a long process of consultation with our existing research users as to what they needed to get out of the storage system and what their workflows required in the next phase, the next 5 or so years of their work. And so collectively what that left us with was the idea that we needed to continue to invest in large-scale tape storage, but we also needed to greatly increase the size of our disk storage. And what we didn't want to do was expand out our very fast disk-based file systems for that work, because they're quite expensive. And we also knew we needed to reuse our existing tapes, because there was about a $12 million sunk cost in the actual tapes in our tape storage system. We didn't want to have to buy new ones. And so we ended up with one key priority for us was at some level providing a kind of simplicity of interface to users. And our decision there was to require an S3 interface, which is a web protocol for accessing data. And all our storage systems would have to be able to provide that. That was like a very high level kind of requirement. And the other part of it was, very technical requirements on what those storage systems need to be able to do. And then we went through this process of actually figuring out like what was the kind of the somewhat optimal way of investing both in the tape system and this new disk-based object system. And we kind of went through that and then started the procurement. Actually bought all this infrastructure and then got it up and working. That work was completed for both systems in the earlier part of this year.
Nice. So now that they've completed and on the floor, what does the usage and uptake look like for these systems?
So well, really good. We're really happy with both the performance of both systems, and our research users that are using those systems are telling us that they're very happy with how they're performing. Our own observation of the performance of those systems suggests that we have really hit a storage system which is both able to provide very fast, large-scale storage for data sets that need to be frequently accessed, as well as this big volume storage for these big quiet data sets. And that was like a key outcome. But the other one is that researchers can actually put data on our systems and then share that easily with external collaborators internationally. We have a lot of that work happening in the center, and that's all working really, really well. So, researchers are sharing terabytes of data out with international researchers, and that's all working. So that's great. I guess one metric, for how well a system like this is going is how many people are complaining. And so far, no one's complaining. Everybody's telling us that they're actually really happy with how it's working. And it has been, though, a transition. So the transition for our research users has been towards using these S3 interfaces for accessing their data and away from some of the other mechanisms they were using in the past for accessing data. And that has not been the easiest transition. When we went into this whole process, there was a lot of work, and there has been a lot of work around helping research users migrate from their existing ways of accessing data to these new ways of accessing data. And we've provided a lot of assistance around that. That's going well as far as we can tell. So in the sense that some of our larger research clients, especially in radio astronomy, have migrated workflows to using this new S3 storage. And it's still an ongoing process. We're not 100% of the way there yet, but we're getting there over the next few months.